Hi students, very good morning. Today we are going to discuss fourth unit. The fourth unit topic name is uncertain knowledge and reasoning. This is the fourth unit. The fourth unit may contain six different contents are there. In that the first one is uncertainty introduction, and second one review of probability. Third one, probabilistic reasoning, Bayesian networks. And fourth one, inferences in Bayesian networks. And fifth one, temporal models. And the sixth one, hidden Markov models. So these are the six contents are there in the fourth unit. So today we are going to discuss the first one, uncertainty introduction. Uncertainty introduction means, so under this one we are going to discuss acting under uncertainty. So how to act under uncertainty. So about this we are going to discuss in the first concept of fourth unit, uncertainty introduction. So let's go into the concept, what they say about uncertainty. So most intelligent systems have some degree of uncertainty associated with them. So what they are saying is, if whatever the intelligent system, so if you prefer any one of the system is more intelligent, even though such systems may contain some degree of uncertainty associated with them. That means here what is meant by uncertainty? Certainty means what's going on there. So about that environment or situation we have the knowledge. But uncertainty means we may not have the knowledge. We may not have the idea on particular concept or anything or situation. So such a data or such a situations we are saying as uncertainty. So if it is an intelligent system also, such systems also contain some degree of uncertainty is associated with them. So how to deal such type of uncertainty, that is we are going to discuss here. So uncertainty may occur in knowledge-based systems because of the problems with the data. So how these uncertainty is occurred means in knowledge-based systems the data may have some problems. Due to those problems in data, we are facing this type of uncertainty. So what are those problems? Means the data might be missing or unavailable. So in the knowledge based systems, if the data is missed or the data is unavailable, then automatically this type of uncertainty problems are arises. Then the second one is data might be present but unreliable or ambiguous due to measurement errors, multiple conflicts, measurements, etc. Okay, in the first point we said data is missing or unavailable. Due to that, problems are occurred. But in the second point, data is there, even though we are getting uncertainty. How and why means what is the data we have? It is unreliable. Unreliable means we may not trust the data, and those data we feel that is not suitable for our problem solving. So such type of data is there, or the data is ambiguous, that means problematic one. Even though data is present, if that data facing all this problem also, it also create uncertainty. This is the second point. And third point is the representation of the data may be impressive or inconsistent. So how you represented the data, that is not impressive and it is inconsistent. Inconsistent is confused. So in such manner if you represented the data, even though such data creates uncertainty. So these are all the causes of creating uncertainty. And the fourth point, what they are saying about the data for creating uncertainty is some data may just be experts' best guess. So the data is not truly happened data; it is a guessed data. So experts guessed this data. Such type of data is also create uncertainty. Why? Because means actually happened data we can easily used for problem solving without any difficulties. But guessed data means we feel something. It is not the true data, or we use or we may not use. So such type of data is also create uncertainty. Then data may be based on defaults, and the defaults may have exceptions. So in some databases, we are filling some default data. So they are not actual. If the columns are empty, so to fill that columns, we are filling default data. So such data, such default data may also create problems. So, given numerous sources of errors, the most knowledge-based systems requires the incorporation of some form of uncertainty management. So, we provided numerous sources of error data. So how many different types of error data we may have and how they are creating uncertainty with the help of knowledge-based systems. So how to overcome this means there is only chance they have some form of uncertain management schemes. So with the help of those schemes, management schemes, uncertain management schemes, with the help of those schemes only, we can overcome the problem, these types of uncertain problems. So for any form of uncertainty schemes, we must be concerned with three issues. So to solve the uncertainty, we use some management schemes. So if any uncertainty schemes, if you take any form of uncertainty schemes, we are facing three issues. So in that uncertainty schemes, what are those means? First one, how to represent uncertain data. So the uncertain data, how you are represent. So how we want to represent the uncertain data. This is the first issue. If you use any uncertain scheme to solve uncertainty means such uncertain data, how we want to represent. That is the first issue. Because we don't know. If we know the true data, we can know how to represent that one. But this is uncertain data. There is no clarity about this data. So such type of data, how you want to represent. This is the first issue in schemes. So to overcome the drawbacks of uncertainty, we have some management schemes. In any scheme, we have these issues. In that, the first issue is representing the data. Then second issue, how to combine two or more pieces of uncertain data. So if we have certain data, that means without having any confusion, if we have the data means we know how to combine. But if a confused data, wrong data is there, we may not know how to combine that data. Such type of data comes under uncertain data. So we may not know how to combine two different pieces of uncertain data. This is the second problem. Then third one is how to draw inferences using uncertain data. So by using uncertain data, how to draw the inferences also we don't know. So these are the three major issues we are facing in any form of uncertain schemes. So for that, probability is the oldest theory with a strong mathematical basis. So to overcome this uncertain problem, so one of the oldest theory is nothing but probability theory, and it is the strongest mathematical basis. So with the help of probability theory, we can solve some problems in uncertainty. So what are the other methods? Other than probability, what are the other methods for handling uncertainty are Bayesian belief network, temporal models, hidden Markov models, certainty factor theory, and Dempster-Safer theory. So these are the 5 different other methods are there for handling uncertainty. So unfortunately, agents almost never have access to the whole truth about their environments. So already we said, if any intelligent system, it may contain some uncertainty. Why means all the agents never access the whole truth data from their environments. So why? Because means agents are performing the actions. To perform that action, we want to access the data from our environment. In that manner, when they are accessing the data, never any agent never access the whole truth data from their environments. So this is the main basis to achieve uncertainty. So agents must therefore act under uncertainty. So always agents are acting under uncertainty. So this is the concept. So always, so if agents access truth data, then there is no uncertainty. But always agents accessing some uncertain data from their environments. That's why agents always acting under uncertainty. For example, an agent in the campus world has sensors that report only local information. So we already know campus world example. So in that example, a campus is there, it moves to the spires to catch the gold. But in that way, we have bits, fires, etc. etc. So how it is moving means based on sensors, sensing the nearby squares. If they are safe, then it moves. But in that example also, the sensors are providing only local information. It is not providing the whole information. It provides only local information. Most of the world is not immediately observable. So with the help of that sensing, we may not observe the whole world immediately. We are observing only partially, the nearby square only we are observing. So that's why we are saying it is not immediately observable. It is a partial observable only. So the campus agent often will find itself unable to discover which of two squares contain a fix. So at the same time, in the campus world also, the agent may not find out fits in two squares. So unable to discover which of two squares contain a fix. So first one time we want to find out in one square. Afterwards only it moves to the next side. So uncertainty is there. So always our agents are acting in the uncertainty. So if those squares are an route to the goal, then the agent might have to take a chance and enter one of the two squares. So always in the campus world, two ways are using or want to use for find out the goal means. So the campus world agent first move in one direction, afterwards only it choose the second direction. Okay, so one by one it is moving. So it is not, so both ways are useful for find out the goal, even though they are not used, but it move in one direction. Afterwards only it move in the another direction. So this is the concept of campus world, diagrammatic representation. Then the real world is far more complex than the campus world. So compared with our campus world example, the real world is more complex. So always it contains more uncertain data. So for a logical agent, it might be impossible to construct a complete and correct description of how it acts will work. So that's why in the real world, it is highly impossible to construct a complete and correct description how the agent wants to work. So based on these concepts, we have some examples. So airport problem is there, and some other examples are there. That the first one is reaching airport problem. So reaching airport problem is, I will give you the idea. So for example, if you want to travel from Chennai to Hyderabad through flight, you want to reach the airport. So reaching airport problem. You want to reach means, so what we are doing, we are based on the departure time of the flight, we are get ready from our home and calculating how much time is taken from home to airport. Based on that, we are reaching the airport. That is the problem. Suppose, for example, that the agent wants to drive someone to the airport to catch a flight and is considering a plan. So you want to drive the car and you want to move to the airport. For that, he planning. So when I want to start and how much time it taken, everything. So I go that involves leaving from home 90 minutes before the flight departs and driving at a reasonable speed. So, for the flight departing time, before of that 90 minutes before he started from the home, that means 1.5 hours is enough for him to travel from home to airport if he with a reasonable speed in his car. So if he planned like this, then what will be happen? Even though the airport is only about 15 miles away, the agent will not be able to conclude the with certainty that plan ago will go as to the airport in time. So even though only 15 miles distance, the agent planning for 1.5 hour time to reach the airport. Why? Because means, so there is a chances to go wrong in his plan. So what are those? So I will give it here. Instead, it reaches the weaker conclusion. So in the plan, the stronger conclusion is, so in 90 minutes with reasonable speed we can reach the airport. But weaker conclusion, the plan I go will go as to the airport in time. What is the plan? To go to the airport in time. As long as my car does not break down, the car is not break down anywhere, then I can reach the airport in time. But are out of gas and I did not get into an accident and there are no accidents on the bridge, the plan does not leave early. And so he planned like this. Why he planned only for 15 miles distance, he taken 1.5 hours. Why means, if there is no problem, he can reach the airport within the time. But if we have, these are all the problems, either breakdown or out of gas or an accident or any accidents in the bridge. If all these happen, it may take more time. If those things are not happen, he can reach the airport within the time. If these things are there, then he may not reach the airport. That's why it takes more time. So none of these conditions can be deduced. So the plan's success cannot be inferred. That's why due to this, if the plan go reaching airport concept, we cannot infer whether the plan is success or may not be success. So always these types of concepts in uncertainty, because he planned to reach the airport in time, but most of the problems are, if the problems are not happened, then he can reach the airport in time. If the problems are happened, then he may not reach the airport. So that's why the last line, plan's success cannot be inferred. It may not inferred. So this is an example of the qualification problem. Then now we are coming into the points of this concept. So the concept of uncertainty introduction may contain 3 points. One is handling uncertain knowledge, and second one uncertainty and rational decisions, and third one design for a decision theoretic agents. So among these 3 points, first we are going to discuss handling uncertain knowledge. So what is this? So how we are handling uncertain knowledge. For that, a small example is taken here. Dental example. Dental. So let us try to write rules for dental diagnosis using first order logics. So with the help of first order logics, write a rule for dental diagnosis. Dental diagnosis means checking the teeth, whether there is a cavity or any problems are there. That is comes under dental diagnostics. With the help of that, using first order logics, we are writing the rule so that we can see how the logical approach breaks down. So when you are writing such type of rules with the help of uncertain knowledge, how the logical approaches are breaks down. So uncertain problem, what are the problems are occurring when forming these types of rules. So first one, consider the following rule. So this is the rule we have found. For all P means person, for all people or persons, symptoms. For the P is toothache. So for that person, toothache means tooth pains are happen. So it implies diseases. So tooth pains are there means then there is a disease. So what is the disease for this person? Cavity. So we know what is meant by cavity. The tooth became decomposed position. Cavity is there. So always toothache is there. He found the rule is the person may contain cavity. So how the uncertainty is there? The problem is that this rule is wrong. Why means not all patients with toothaches have cavities. So for all the patients, if heads are there means it is not, we are not concluded it is a cavity. May have some other problems are there. So that's why this rule is wrong. So for this, what they are doing? Some of them have gum diseases. So if you have toothaches, you can say some gum diseases are there, or abscess are there, or some of them are several other problems are there. We may not say it is cavity. So what is the rule we found is wrong. So due to uncertain problems, we are forming these types of rules. So if toothache is there, it is not the cavity. We have some other problems also, maybe gum disease or abscess or any other problems. So how you want to form the rule in this manner? So for all person P's, the symptom is toothache means the disease of that person may be cavity or the disease may be gum disease or maybe any abscess. So if you form the rule in this manner, it creates some certainty. So unfortunately, in order to make the rule true, we have to add an almost unlimited list of possible cases. So if you want to make the rule in a right manner, means you want to add more possible cases. So if you add like this, then it creates, the rule creates some certainty. If you form the rule in before like that, it creates some uncertainty. So in medical environment, what are the problems are creating failures means, come to this one, trying to use first order logics to cope with a domain like medical diagnosis, thus failure for three main reasons. So in the medical environment, while the failures are happening means based on these three main reasons. One is laziness. The medical environment, if you have any problem, immediately we want to react. If we are in lazy, it creates problem. That is given. First failure reason is laziness. It is too much work to list the complete set of antecedents or consequence needed to ensure an exceptionless rule and too hard to use such rules. So laziness create the first reason for failures in medical environment. Then second one is theoretical ignorance. So ignoring the medical environment. So medical science has no complete theory for the domains. So second problem is theoretical ignorance. Then third one is practical ignorance. Even if we know all the rules, we might be uncertain about a practical particular patient because not all the necessary tests have been or can be run. So practically means, so laziness means due to laziness we are failuring in the medical environment, or not having theoretical knowledge we are failuring. Then practical knowledge also. If a patient has some problem means we want to run all the tests. So based on the tests only we can conclude if he has some problem. Without doing that we may not conclude. So based on these three reasons we are failuring in the medical environments or medical domain. So these are the three reasons. One is laziness, and second one is theoretical ignorance, and third one is practical ignorance. The degree of belief. So the how we are measuring the uncertainty means based on degree of beliefs. So what is this degree of beliefs? The agent's knowledge can at best provide only a degree of belief in the relevant sentences. So how the agent knowledge we are testing means it is the best. So an agent always providing the best knowledge and provides only the degree of belief in the relevant sentences. How it is believing. So that person will be, the degree will be given to that. It is the best concept. How much it is best? It gives the degree of belief. So the main tool for dealing with the degree of belief will be probability theory. So how we can providing that degree of belief? Degree means a point, a number is given to that. So how to deal this degree of belief is with the help of probability theory. The degree of belief always numerically we can provide in the form of between 0 to 1. So I believe this concept at 0.5% means only half percent, 1%, 0.1, 0.2 or 0 means we are not believing. So the most important tool for belief concept, finding out the belief is probability theory. So always probability theory is the value between 0 and 1. The probability theory makes the same ontological commitment as logic, namely that facts either do or do not hold in the world. So either that concept may be there or not there. So the degree of truth as opposed to degree of belief is the subject of physiologic. So physiologic is nothing but the degree of truth or degree of belief. So how much the main truth and how much the belief. So the versus degree of truth versus degree of belief. This concept is nothing but physiologic. Finding out how much we believe in and finding out how much is the truth. So this concept is comes under the subject of physiologic. Then evidence. So for an agent wants to act means he must require some evidence. So what is this? The probability that the patient has a cavity is 0.8. So a patient, if the tooth acts are there, tooth acts are there, so we can conclude 0.8% we are believing, the agent believing 0.8% the patient may have cavity, not directly about the world. Okay, so he believes only 0.8. So these beliefs depends on the percept that evidence the agent has received to date. So this number, the cavity is 0.8%. How we are providing means depends on only perception. Agents always percepting the environment. Due to that perception, he believes, agent believes this much of amount the patient may contain cavity. Other 0.2% may have other problems. So these percepts constitute the evidence on which probability assertions are based. So all probability statements must therefore indicate the evidence with respect to which the probability is being assessed. So all the probability statements are indicating the evidence of assertions, how much we can assess the problem. So for that, this probability statement giving some evidence. So as the agent receives new percepts, So if we perceive that environment, we are providing some probability concept. If the agent receives any new perceptions, the probability assessments are updated to reflect the new evidence. If new perceptions are there, then new evidence are there. So before the new perceptions, before the evidence is obtained, it termed as prior or unconditional probability. Before the new perceptions, what is the concept is there? Evidence is there. It is called as prior or unconditional probability. If the new perceptions are happened after the evidence is obtained, it is termed as posterior or conditional probability. So two things are there. So always a general perception is there, then we are having some evidence. So this much amount we have the problem. So if any new perceptions are happen, automatically the evidence is also changed. So before new and after new. Before new it is called, before new what is the evidence we have, it is called as clear or uncertain probability. After that, after the perception, we are saying the evidence is posterior or conditional probability. These are the two different types of environments we have in probability environment for evidence. Then second point, that is the first point, handling uncertain knowledge. Second point, so how we are maintaining handling means with the help of probability is the main thing. Then uncertainty and rational decisions. This is the second point. What is this? An agent must first have preferences between the different possible outcomes of the various plans. So always, if you want to execute the artificial intelligence concepts, we are planning. So based on this plan, various plans, we are getting different possible outcomes. So the agent wants first prefer those possible outcomes. So a particular outcome is a completely specified state. So from all the outcomes, some particular outcome is a completely specified state. So include such factors such as the agent arrives on time and the length of the wait of at the airport. So always it provides a complete structure. Correct structure means then the utility theory is used to represent and reasons with preferences. So always if it is a complete state, only you can use the utility theory to represent the reason with preferences. So why you want to prefer this particular concept? So for selecting these preferences, we want to use utility theory. So with the help of utility theory only, we can provide or represent the reason with preferences. So the term utility is used here is the sense of the quality of being useful, not in the sense of the electric company or other works. So utility means how qualitatively you are useful. For example, in the reaching airport problem, he planned 90 minutes before he want to start from the house to reach the airport. So if he completely used that one and reached the airport perfectly means to find out or represent the preferences, how we prefer the routes, everything, we want to use utility theory. So utility theory always used here in the sense of quality of being useful. To represent the qualityness, we are using the term utility, not for any other purpose. So utility theory says that every state has a degree of usefulness. So utility theory always says the usefulness of the every state or utility to an agent, and that the agent will prefer states with higher utilities. So if it is a complete and it is a correct state means, then utility theory always provides it is the state with higher utilities. So preferences as expressed by utilities are combined with the probabilities in the general theory of relational decisions called decision theory. So if you want to take any decisions, we require preferences also. These preferences are expressed in the form of utilities and the combination of probability theory also. So in this manner, the rational decisions are called as decision theories. So if you want to take decision theory decisions, we must depends on utilities and probability environment also. So decision theory is equal to probability theory plus utility theory. These two concepts must be required. So the fundamental idea of decision theory is that an agent is rational. So if you want to find out the fundamental idea of decision theory is the agent is rational if and only if you choose the action that yields the highest expected utility averaged over all the possible outcomes of the agent. The fundamental idea of decision theory is the agent must be rational, then only he can choose highest expected utilities and the possible outcomes of that action. So this is called the principle of maximum expected utility. So this is the concept of rational decisions. So if you want to take decisions, means you must require probability theory and utility theory. In the utility theory only, we are discussing about the preferences. So which one we want to prefer. So that's why to find out the rational decisions or decision theory, you must require probability theory plus utility theory. So this types of principle is called maximum expected principle. So maximum expected utility principle. So this is the point of second one. The third one, decision design for a decision theoretic agent. So to design the decision theoretic agent is what are the things we want to form is the given below sketch the structure of an agent that use decision theory to select actions. So structure means it gives the some algorithmic format. Based on this one, we are designing the decision theory for agents. The agent is identical at an abstract level to the logical agents. So agent must be identical. The next one, the primary differences is that the decision theoretic agent knowledge of the current state is uncertain. The agent's belief state is a representation of the probabilistics of all possible actions actual states of the world. So always when you want to design any decision theories for agents, the initial state is uncertain. So based on the belief states, you want to represent the possible action states depends on the probability of the world. Then as this time passes, the agent accumulates more evidence and its belief states are changes. So initially he may not know anything, he is uncertain state. When the time is passing out, the agent accumulating more evidences and its belief states are changed. So he carrying more data, then only he can move forward. So this is nothing but the sketch. So at starting, decision theory, the agent percepts and returns actions. So always agent wants to percept the data, finding the data and want to perform the actions. So for the static belief state. So in this decision tree, we want to use belief states. So probabilistic beliefs about the current state of the world and actions agents update. So always when you are using the uncertain concept, your belief states are changing based on the actions and perceptions what we are doing, and finally calculating the outcomes of the probability actions. So just come to the point. So in uncertain environment, we want to use decision theories. In the decision theory, always the agent wants to perceive the data and perform the action. So these perception and these actions always depends on belief states, how you are believing your perceptions. Based on that, how you are action performing the actions. So based on that, you want to calculate the outcome probabilities for each action. So that is given here in this sketch. So this is the concept of uncertainty introduction or acting under uncertainty. So in this concept, what are the points we need to remember is first we are providing the introduction about this uncertainty and we have three different points. What are those means? First point is handling uncertainty knowledge, how to handle uncertainty knowledge, that is the first point. Third one, uncertainty and rational decisions, so how the decisions we want to take. And third one is design for a decision theoretic agents. These are the 3 points are available in this uncertainty introduction concept. Thank you.